Hello people, welcome back to the corgi64 project. In this episode we're going to finally work on creating these flags for arithmetic. So if we go back to our CPU design text, eventually we'll want to create these branch functions. So what we're going to do is we're going to actually implement our flags register. And so if we look here, there's actually 4 different flags that we want. We want a 0 flag, a negative flag, overflow, and underflow. We're actually not going to worry about overflow and underflow right now. In fact, we may end up removing these instructions from our instruction set because we may just want to make that undefined behavior, and that will simplify our system. Either way, we're going to leave that for later, and right now what we're going to do is we're going to implement our 0 and negative flags. So what we're going to do is go back up here, and I added some text here for our flags. And what I'm going to do is I'm going to just remove this overflow and underflow right now, and we're going to implement 0 and negative bit flags. So if we go back to our CPU.h function, we're going to go, and for right now we're going to change every arithmetic operation, and we're going to implement setting a flag. So what we may do is we may pull this out into a function, and there may be other ways that we'll actually implement this later that will be more efficient, but for right now we're going to do this the simplest way possible. So we're going to check if CA is 0, and if it is, we're going to set our flags register. We're going to set it to, we're gonna actually OR it. We're going to do bitwise OR with 1, and what that will do is that will make sure that all the other flags that we have don't get unset. We're only going to set our particular flag. And if we go back here, you notice that our flags register, it's actually 64 bits long, and we're only using 2 right now, 2 bits. So we have plenty of room for expansion for other flags and other things that we want to notify the CPU of in the future. So there's plenty of room for expansion here. So if we go back here and we do else if CA is less than 0, then we want to set the negative flag. So we'll say flags, we're going to OR it with a 2, which will set the negative flag. And then we also want to set it if it's positive. So if we have a positive number in our A register, what we want to do is we want to set our flags, and we actually want to unset or make sure that that flag is unset. And the way that we're going to do that is we're actually going to AND it with the reverse, was it 1's complement of the 2 flag. So that's the I think this is the equivalent. We're going to have to test this to make sure, but I think this will give us the 1's complement of 2 here. And that is essentially what we're going to do. So we'll take this. Actually, it looks like in every one of these things we're going to have the A register. So probably what we should do is actually, just to simplify things, we're going to create a void set let's see, should we do a set flag? Yeah, we should do a set flag. Set flag, and we're going to say answer. Let's see, what are we going to have? We're going to have an I64 value, and then we're also going to give a CPU pointer to our CPU. And then what we can do here is we can actually add this here, and we can look at our register. Actually, we can just take CPU. That will allow us to do that, and then that will allow us to set, this will allow us to set like an arithmetic flag. And so we'll check the A register, and we'll set the flags accordingly. And so then we can just do this. We can take this, and we'll go set arithmetic flag, and we'll give it our CPU. And then we can just copy this and add it to all of our arithmetic functions. So we can add it to subtraction, multiplication, division, and modulus. And that will set our arithmetic flags. So now we can test this out. We can say, okay, let's test a let's see, where we go. We're just gonna test with, say, test void test. We're gonna have 0 flag, CPU, and we're also gonna write a test for our negative flag, and maybe we should put an underscore there just to be consistent. So now we have test 0 flag, we have test negative flag. So what we're going to do is we're going to actually set up our registers. We're going to set A to be 0. We're going to set the B register to be 1, and we're going to do a sub. So what this should do is, if we have a subtraction, we should subtract B from A, and then we should set an arithmetic flag, and this will check if CPU print status. And we should also assert that the flags register equals, let's see, 0 flag should be set, so we'll set it to 1. Now technically when we assert this, if we had done anything else with the flags above the in the tests before, right, there's possibly other flags could be set. We really only want to check if the first bit or the 0th bit is set here. So we may rewrite this later, but for now what we're going to do is we're just going to set this flag. And in fact, what we're going to do to reset, actually, do we set when we, let's see, let's go back over here. Do we have a reset function for our CPU? Yeah, so we have a reset function where it sets all of our flags and the instruction register. Okay, so maybe what we should do is we should actually reset our CPU to make sure that it's all clean in our tests, and that way we know that this flag will actually be a 1. So let's go ahead and do that. We'll say, was it called CPU reset or just reset? Well, it's called reset. Probably have to change the names of some of this stuff a little bit later, but that will take care of negative. Or that will take care of, actually, so this should be 0 minus 0, and that should give us a 0 flag. There we go. And over here we want to have a negative flag, so we're going to subtract 1 from 0, which should give us negative 1, and so this should give us a 2 here, right? So the flag, the bit should be set in the second bit, or the first bit, if you count from 0, and then we can print the status there. So let's do test 0 flag and test negative flag here at the bottom. This isn't an exhaustive test, but it'll be good enough to see what we're doing. So test negative flag. And there we go. So now we should be able to run these tests. So if we do, if we do build test, there we go. Let's see, syntax is not a prefix operator. Oh, so how do we That's a good question. Let's do a lookup real quick of. Let's do a lookup real quick on C++ operator complement. Let's see what happens. So if we want to get the bitwise complement, oh, so maybe it's the tilde. So I was wondering if it was the tilde or that negative numbers are stored as 2's complement, right? So, okay, very good. So the complement operator just flips the bits, which is exactly what we want. So let's go ahead and use the complement operator. So let's go back over here, and in our cpu.h, we should scroll up a bit. We want to go back to where we have our flags, set arithmetic flags, and we'll, instead of the caret, we're going to use the tilde. And then we should be able to build our test again, and it looks like we got an output. So if we do bin tests.exe, looks like all tests passed. And if we look at the last two tests, we get the flags. Flags was 1, and then flags was 2 at the very end, so which is exactly what we want. So that's very good. So that is all that we're going to cover for today. We now have enough put into place where we can actually build some of these jump routines, right? So we've got, we should be able to jump based on flags and to different subroutines and do unconditional jumps. So once we get our jumps put into place, we'll have essentially everything that we need for, or everything will be put in place for a minimal processor. And all the other stuff that we're going to put in there is actually for speed and kind of not necessarily simplicity, but for ease, right? Ease of use, right? So you could using regular arithmetic create your own bitwise and OR and XOR and your own bit shifts, but we're going to add those in there just to make it way easier to program and also to make our machine far more efficient than it would be if we had to write our own version of these bitwise functions. In fact, some of the old processors did not have a multiply instruction, and you had to write your own code for multiply. So luckily we put that in there, and so thank you for watching. We will get back to those jump instructions next time.